Hello and chill, everybody. It is Mike Levin on Saturday, March 6, 2021. And this is the continuing in my video series of the most important yet boring foundation stuff you'll see on, well, I guess it's a NB Dev Hello World is what we're talking about. I'm taking up a new tool to help you turn Jupyter Notebooks or labs into a more legit dev environment, which it already is in so many ways. It's where VS Code is lifting many of its things from. So, avoiding that rant, when last we left off, I was showing you whether you were in a Jupyter Notebook or not. This is going to output true when you're running it from Jupyter Notebook, and when you're not, it will be false. When it's from the command line, it'll be false. So much of what this is about really is using Jupyter Notebooks, to make command line arguments, command line commands, supporting arguments for scheduling, which is like another approach to automation from web serving. Web serving, etc., because there are other approaches to automation. This sort of automation in the olden days was referred to as cron, but nobody really wants to deal with cron anymore. So you deal with the scheduling API of your choice. Started by an init process. Okay, so you take command of a machine, you say run the scheduler, and with that scheduler run the following things according to this schedule under Python or whatever environment you use. And so you've got to be able to write it as a command line so it can be scheduled in a system like this. And then you need to parse the arguments that you're feeding in. So that should give you the, forest trees context. And I'm going to show you how to do that from Jupyter using the built-in standard library, avoiding various issues that come up when you're using the fancy and alluring third-party packages that help you in this mission. I will not be doing that. I'll be just using the standard library. Speaking of which, we've got an import to do. Now, I should put this towards the top by convention, but I will actually type it here for now as I remember what it is, the magic incantation, and complain a little bit about some of the Python magic incantations are very inconsistent. From argparse, notice two abbreviated words, all lowercase appended together, import the part of it we really need, which is the argument, uppercase, full word, no abbreviation, parser, again uppercase. So that's Pascal notation, they call that. People sometimes call it camel case, which technically it is. It's a two-humped camel, but that can be ambiguous. This is specifically known as Pascal case. And we've got the argument parser, and we're going to need two subparts of that. We're going to need to parse our arguments, and we're going to need to add a new argument. So I'm going to double check my notes because, again, the magic incantations here get a little bit fuzzy for me, and it is in fact add argument and ParseArgs. So add argument and ParseArgs are the two things we're interested. So I'm going to just note those right here. Add argument and ParseArgs. Okay. So one of the big reasons, one of the things driving people to third-party packages is because this gets very verbose. So I'm using this as a reminder because I'm going to need to use those in a moment. You need a parser object. and your parser object becomes an instance of argument parser. So already we're abbreviating things. This could be worse. This could be argparse.argument parser if we did the shorter import statement. So at least we have this, okay? So things get really verbose again as you use the parser to add an argument, because argument parser has these sub-functions or methods of add argument. And this other one is less in need of abbreviation because you're going to only do it once at the end of statements, but you're going to be adding an argument over and over. So it does help us to say add arg. I can do my own new version yet, both lowercase abbreviated with an underscore in the middle, as I think a good API should be, and that is going to be an instance of my add argument method of my parser object, which actually is in memory. So now I can just add args, hence taking care of the biggest annoyance of argparse, the built-in way of handling arguments of it's so darn verbose. So I'm not going to need this guy anymore. I'm going to keep this other guy around because I'm going to need it. So where are we going to add our args? It's time to actually use our add arg arguments and add a few of them. Well, it's a natural place to start doing it at the bottom of our file so far. We have this nice is Jupyter check where we're just printing is Jupyter. However, it would be even nicer to say jn equals that function. And then we can just print jn and it'll give us the same output. However, this time we are now at least sitting on top of the jn Boolean for an if statement. First we can print it, so that value is still there. True, we're in Jupyter. So we can easily say if jn print in Jupyter, no command line args, silly, else print you had better add some args, dude. All right, you're in Jupyter, so there's no command line args, silly. Let's demonstrate the main takeaway from the videos leading up to this. We can export that. All right. Now I'm going to clear the whole notebook. I'll run it top to bottom on the clear. Control-Shift-R, that should run it. If it doesn't, I got to check my binding, but basically I was going for a restart kernel and clear all outputs. I need Control-Shift-E for everything. You can clear all outputs and run everything. This is a good exercise just to make sure that your notebook's in good condition. And I left this comment here. Let's make it a real comment. That's what comments are for. Control-Shift-E again, restart. So we like to see it reaching the bottom. If any errors occur, it won't reach the bottom. And now I can do my Control-Shift-R to clear it, because that's what you want to do immediately before a git commit. Now, we're in that directory. I was doing some diffs on it before. I can clear, and then I can git status, see my differences since the last time I did anything to this, and you can see I've done a few modifications, and let's look at the diffs. Git diff. You look at your diffs. And you got all this metadata here. This will be a great example now of what the tools of pre-git commit do to clean up your notebook. There's a lot of unnecessary lines added due to the nature of it being a notebook. So nb dev clean nbs, that cleans your notebooks. Now there's going to be presumably a different diff we can look at. It still has quite a bit of metadata in there. That's interesting. It might actually be correct. Each one of those is a cell, and I added a number of things. Yeah. Okay, it's actually correct. I got to give it credit. So I've cleaned the notebook. I will nb dev build lib singular. Now the other thing I could do is build the docs now, but I'm not going to. Git diff again. Now that I've built the docs, I should see some slightly different things in there because there's been some other files updated, and this is longer. I'll look at it more carefully, but suffice to say, one of these is a .py file that's automatically generated by that process I just did. So we're sitting in that directory where it lives, so I can run that. So it goes python core.py. You had better add some args, dude. So let's add some args. And we've confirmed that when you run it one way, it shows you one set of output, and when you run it another way, you show another set. This is my logging. I am error logging. It's currently showing to standard output and not an external file. We'll go over that in the future. We're showing whether you're in Jupyter environment or not. It's reporting false. You know you're not in Jupyter. And so it's saying the next step in our tutorial. Here, when you run it and you get down to that part, it's going to tell you something different. It's going to say you're in Jupyter, okay? So let's make it so that there's actually arguments. And we're sitting on top of this wonderful stuff now. We've imported the arg parse, the argument parser. We've created an instance of it. And then we've created an abbreviated notation of something you reach down to, which would be a very long path. And so let's do it. We check our notes because I'm still learning this myself. I'm trying to get it into my muscle memory, such as it is. And add argument, the API for it. Yep. So we will be hitting Google because I need to see how to use argparse in an example. Python argparse. We go to the main documentation. It'll probably be the 3.9 stuff, but that's fine. You see those paths. It's good SEO they have on this site now. That it stays around as the same URLs for as long as the top increment is the same, and it just updates to the latest. Anyway, in here there's going to be a add argument right there, right? So we see the syntax. Here's the long double lines that you can give. So you can use these short versions of the parameters as well, the -h's. So we want to make sure we're encouraging the use of the long and the short with alternatives to each other. So it should be pretty easy to see how we support that. Yeah, so these are the reasons sometimes that are given for this being not the best API. I mean, to go to the Python documentation directly itself to get these answers, add arguments. Listen, you have to look through a lot of stuff. And here is, yeah, this is it. So I'm seeing a short version, a long version, and something you can do for extra parameters. So this is basically my answer. You put in the actual short version and the long version, and it gets passed in using either word. And I believe it has some parameters like required equals true or false. That's the last one I'm interested in. Required. Yeah, it's a Boolean. Yep, required equals true. So we have all our answers. Files changed. We are going to overwrite. We're going to just keep what we have because, we're just going to be rerunning cells and stuff. So it goes, our abbreviation, add arg up. So yeah, it loaded what was in memory anyway. Doing it here, add arg, and short version, argument x. Now let's use a more conventional expectation. You're going to always have to feed in, say, a file name. So file required equals true. There we go. So 2 positional arguments. So there's API issues here. I am abbreviating this whole thing by using the 2 traditionally position-sensitive locations, I would assume, or it's parsing the input and figuring it out from usage. But position 1 for the short notation, position 2 for the long notation, and whether it's required or not, right? Oh, low battery. Let's see if I've got a battery here. We're going to keep this video going because I like this video. It's going well. And if you like it too, you can hang for a moment while I solve my battery situation. Yeah, let me pause. And we're back. So when last we left off, we added 1 argument. Okay, so this is like a hello world of argparse. And this is a pattern you would generally see repeated over and over. If we were to support another arg, we would make it an optional one. File, we'll call it, description. Great example of why people often don't like to use the long version. It's much easier to type the shorter version, and we'll make the description optional. All right, so we've added 2 arguments, and still inside that indent, because we know we're in the context of being in something that is not Jupyter Notebook, we can invoke the ParseArgs method of the parser. That's the parser we're talking about at this point. So it's an easy enough pattern. You've got to actually call it here. Just the way these are being called with methods, same things. You're calling the method, and that is going to actually parse the args that have been fed in, but we're going to do the traditional thing of feeding it to a variable name called args, and we can, in fact, here is our last step, print args. So if anything came in on the command line, it's going to print it here. Now, args will not be set here, but it's going to need it if it comes through this path, or else it's going to generate an error. So we can not generate an error and say args equals empty dictionary, or no, we'll give it a message, in fact. But we'll put it in the structure that's expected, which in fact would be, yeah, a dictionary would come back. Key, colon, value, not set. you're in, I guess you can backslash that, you're in Jupyter. And yeah, what did I get wrong? Some little syntax thing. Yeah. This is non-matching. Extra parenthesis in there. We're using a dictionary data type. So, you know, key is not set because you're in Jupyter, right? So I'm simulating args as if key, you know, as if key was one of these. If I were really simulating it, if I wanted to simulate the args here, I could just set the dictionary object arbitrarily, and that is indeed one way to simulate your args coming in from an outside source when you're running it in Jupyter. And that's probably where we'll end this video, how to view them here and then just copy and paste the value up into here. And I might skip over the plan I had of using Pickle to do that, which brings pathlib into the picture and makes it a much larger video. But I think args on their own is a good approach. And then I'll do pickling off single values without that big SQL backending as a following video. That would be a good path. Okay, so to hit this home, we, I guess, want to blanket, Control-Shift-R for restart kernel, clear all cells. And once it's blanked, we can nbdev. I'm not getting ready for a build or anything, so I can just build, it's got to be singular, build lib. Now I can run that Python core command again. And add arg is not defined. Add arg, oh, because that's not in an export. It doesn't see all this stuff because it's not an export. So to make this as part of the module, this is now nbdev stuff, and I can't take this for granted. But I need to merge my cells that need to actually be run. Oh, it's not even the assert. And I need to export those. I might do some export cell consolidations, but I need that in there. I'll get rid of these two things. Make it a little bit cleaner. These two exports in a row. Okay, I'll now combine those together and get rid of the extra export, right? That's a little bit cleaner. And now that's a really good thing because this is going to print args and show you the args that came in. One's going to be required, so this is going to choke if it's not really even there. So nbdev build lib, run the Python script, and it tells you the following arguments are required, -f or _file. So we can give it -f foo. And now it shows you description equals none and file equals foo in the local namespace. That's interesting. So I tell it to print args. Args is applying the argument parser objects ParseArgs method to the parser object that has had a number of arguments added to it. Yeah, this is all correct. So we can output some description. Foo -d for description is naturally bar. And there it is. We print our argument, which is really a dictionary. It's presenting it as a function, as a named tuple type object. But there's a number of things we can do. We can, first of all, check its type. Yeah, okay, so I'm running this over fresh here, so I need to execute a few things in order there. So it's a dictionary type, even though it's presenting itself as more of a named tuple type of looking object. But named tuples, I presume, are back-ended by dictionaries. Anyway, there's a lot of interesting subjects we're on the verge of here that I won't go into because it's basically mission accomplished here. So this is the This is basically the code that people are trying to get away from when they're going to pip install. Now, I don't say necessarily do this, but at this point in a project, it's very common to pip install click or doc opt or one of these other things that steps in to try and make this process easier. But I say, really, there's no reason to do that when you know, let's see what kind of key values are coming out. The full length words are used in the dictionaries. So if you wanted to simulate that output here, you have a file, and this is the value of the file name here, and then you have a description, and that description would be description here. Run that, and instead of printing this now, you can actually print args, see what that shape looks like, the output you've simulated. Well, it's still showing the type, so we don't have to print. We can say, we can print, yeah, right. So there's our simulated input where file is file name here, description is description here, and then you can use that args object through the rest of the document as if the input came from typed in on the command line. But using this API, you can really now make it typed in on the command line, and this controls it. This does that. And when you parse the args, it scans through everything it got in, typed in after the pattern of, the python.exe, the name of the file being executed, and then everything following it. And there's different ways to absorb that data, lots of different ways. The limited key value pair way I'm showing here is just one of many. And there's a lot of criteria you might have, like you can only include certain parameters together, certain arguments together, or one or the other. So all those rules are supported, but I'm really not going to get into them because I think that's a really good wrap to put on that there with this sort of bare bones scaffolding, the stuff that you really want to get into your muscle memory at the beginning. And in the same spirit, I added logging, so it's always there. And of course, Figlet, because I can't live without my dear Figlet. I have also added argument parsing. And this is for this kind of mentality. And perhaps I'll do one quick video I haven't drawn in a while to just put a fine point on what it is I'm accomplishing here, why I'm going through the effort. What is the effort, you say? Well, I do like living in Jupyter Notebooks, even though it's more frequently these days, in other words, all the time, Jupyter Lab. There is a certain love in it. And yes, VS Code too. There is another parallel world going on, almost feature for feature, expectation for expectation between the notebook environment and VS Code, because the teams are very closely connected now by this point. This is all living under a larger context of a mainstream platform. I am using Windows 10. It does not have to be, but it is a great, right now, Anaconda host. But we're trying to get Anaconda out of the picture. We're going to say just a Jupyter host. Now that's hardware generally. That's a Windows 10 machine or such. And now there's this other world that likes to get the PY files and to put them in scheduling systems and web servers and such. So your .ipynb file, these are .ipynb files. The idea is to get a smaller, stripped down version of them here on this platform, where they're really just .py files. And that platform is usually some sort of headless web server type machine. But for the sake of our work right now, it is the Windows subsystem for Linux. And that's what I'm showing you right here on these videos, is showing you an execution context where you can get it from Jupyter Notebook into a Linux-like environment. Right? All on one machine, right? This is all on your machine. Your hardware. No cloud. No cost. But with my recent back-ending, these things you're working on do have SQL access locally. They have NoSQL access using that SQL light dict trick I've been using, and a number of other things. However, even with all these downsides, everything you do can in fact be bundled up and sent off into the cloud if you like. It's all cloud deployable, all right? So that's what this picture is here, and that's kind of a way of saying that it's a really nifty trick to work in this living notebook environment where you can build in documentation. I'm going to start to have to do that. I didn't use doc-opt. I'd have to be building these doc strings that go into your functions, and we'll cover all that. There's so much more that Jupyter Notebook, there's so much more that this whole NB dev environment can do for you than what I've really done it justice showing you here so far. But it is really nifty to be able to develop command line tools. That's what we're doing here. These are, command line toolitizing it, this purple magical color, because, you're creating stuff that lives in multiple worlds. Your work is going out here and being tested and vetted in this environment that until recently, it hasn't been really easy for mainstream Windows people to do. And you test this on a local Linux environment, and when it satisfies your criteria, you deploy it into whatever thing you have here. I happen to use the Amazon Computing Cloud, but it could almost be any server. Any cloud server. It could be a Raspberry Pi, and that's where the real scheduler is, where you've got sort of a 24/7 reliability, as opposed to here, which you would call ad hoc. It could also be called exploratory. There's a lot of data science here. The data science people really love to live here. This other world is a world really of sysadmins. The sexier term these days is DevOps people. They'll be really comfortable here because all your tools are the standard tooling of the Nix world, even though you're on very common, easy to support proprietary Windows hardware. And yeah, it's a good video. Let's put a wrap on that. So now you know how to do argument parsing as a command line tool, a CLI tool. You're developing CLI tools. Follow their way out to being tested as CLI tools and then being deployed with arguments into your CLI tool on a scheduler clock. And there's no cloud cost. You're using SQLite to back-end it. There's generally no cost other than the connection or whatever, the bandwidth. You have access first to NoSQL because you're doing lots of data fetches that fill local caches with key value stores using a third-party library, and then no third-party library at all, just the standard library to connect to that and do some mapping from the NoSQL on the left, key value blob stores, into more appropriate row and column on the right, using, choose your poison technique. I think I'm going to lean towards a sort of, dictionary object field mapping, a dictionary of list comprehensions is what we're talking about. It might be a single list comprehension that addresses all fields in the JSON object, or it might be a series of list comprehensions that each apply to a scan through the JSON object because it's going to be a predictable number of times. It's less efficient, but maybe easier to write. And I'm a little on the fence about that stuff. So, maybe this has been a question that comes up sufficiently that I'll just draw this last diagram quick. And this is hosting. There's advantages. Probably delete all those out anyway. Now I can do new for a new document. Hit OK, and I lost my train. What was I about to do there? There's the pickling. There's that last picture of deploying everything is a command line. Everything is a command line. That's it. I think that puts a wrap on the video there. If I remember where I was about to go with that new picture, I will go there. However, this is setting us up for a great deal of success in the projects to come next. Thanks for joining me. Hope to see you again soon, and don't forget to subscribe.